Hello everyone, this is Murat, and today we are going to build a full stack Web3 application, decentralized application, using Solidity, Hardhat, React.js, and Ethers.js library. And for Ethers.js, we are going to use the latest version, which is 6 point something something. Let me check if I can find. Why I am mentioning this is because this change is recent, and if you go into the documentation, first you see the documentation for version 1 and version 6.3.0. There are some changes in the code. So if you see some older tutorials like a couple of months ago and try to implement the Ethers.js code today with npm install ethers command, you will encounter errors. And so in this tutorial, I'm going to build upon the new version. So let me close this. This is what we are going to build, by the way. I know it's not very beautiful on the front end, but instead of styling, I want to focus on smart contract functionality and how we can interact with it using Ethers.js. So, first, in this tutorial, we are going to build the contract, test it via Hardhat, deploy it to a local blockchain that we'll be creating with Hardhat, with the help of Hardhat. And then we are going to interact with it via Ethers.js. Now, but first I want to show you an error, very annoying error, and how to solve it. I know it's a weird start, you don't start with errors, but it took me a while to figure it out. So normally, this is the application that I have built. Normally, this stake function should work. I will explain what are we going to build to. It doesn't matter right now. It's a function. I want to call this function and I get this error. Where is it? Nonce is too high. Something. This happens I guess when you deploy when you deploy on the local chain and redeploy and try to interact with it, etc. Like when you are working on it, this happens. How to fix it is you go to advanced in your MetaMask, you reset your account. It won't you see, it just resets the transaction history, and now the function should work. Let's see. Now it didn't give an error. Yeah. So it works. I just wanted to show that, like, if you are getting that nonce is too high error, just reset your MetaMask. Yeah, as you can see, to confirm a transaction 1 confirmed. So it's because that, I guess it was because of that you redeploy into local chain and it gets stuck there or something like that. I don't know. It's not important. This is how you fix that when you encounter. So today, the application we are going to build have the following structure. Like, it will be a hypothetical situation where a group of users can stake some of their money for a common object. Like they say, it's a DAO, decentralized autonomous organization. It's a group of people who wants to raise like 10 ethers to buy an expensive NFT. Okay. So there will be a threshold. Actually, I will make it 1 ether. So they can, the users can stake their monies into that smart contract, and if they reach the desired amount of money, amount of Ether, they will be able to execute the transaction to buy the NFT or send it to someone else. If not, we will give 72 hours for the staking process to continue. Like they have to reach the agreement, reach the threshold between until 72 hours is passed. Now, during that time, they cannot withdraw their money, but after 72 hours, if it's not executed, like it's not executable if the threshold is not met and if 72 hours has not passed since the deployment of the contract, then they can, like, if it's not executed, if it cannot be executed, every individual can withdraw their money, so no one loses anything in that perspective. Now it should give an error because 72 hours has not passed, so we cannot execute. And I see that I forgot to add a withdraw functionality, so maybe we will add on the go. Now it's all good. Next we are going to start coding. Okay, now I closed the application and we are going to start all over. So what I'm going to do, actually I did it and I'm going to show you how we are going to use NextJS with CSS, and I want to create a NextJS application with Tailwind CSS with the following commands. Let me see. Yes. When you write npx create next app / tailwind, and with the name of your app, it creates a Next.js app with Tailwind configuration. Also, when you run that, I'm not going to run right now because it takes time, little amount of time, but still it takes time. I don't want to wait and make you wait. Please choose TypeScript because that's what I chose. Then after we create our application, you see there is taking dApp. Let's go there. I create a contracts folder with mekdir contracts. This is make directory contracts, cd into it. I will npm init y to create a package.json file, and I will install npm install save dev Hardhat because we are going to do our development in Hardhat. And after I installed Hardhat, I guess it's npx Hardhat run or something like that, I don't know. I have the Hardhat how to call it, like shortcut version of Hardhat. You can find it on the Hardhat documentation. Let's see. Hardhat. Yes, I'm going to show you if I can easily find it. Like there is this thing when you install it, command line completion. Yes, when you install this command line completion here in the guides, with this you can, instead of npx Hardhat, you can just say hh. Like instead of npx Hardhat compile, you can just say hh compile, and so that's what I did. And when I write hh and press enter, it will start a Hardhat project, and we can install Hardhat. In Hardhat I chose JavaScript. I mean, I don't remember, I guess, like that's what I did, and you can do whatever you want, but this works in JavaScript. Now I guess we can start. Now let's go and start. Right, I have to take it. Let's start coding. So let me check whether you can see clearly or not. Okay, a little bit bigger. maybe a bit more bigger. This is this is too big. This is fine. Like the previous one is too big for me. This is still big, but it's okay. So this is our structure. You see, we have a NextJS app, and I have installed Hardhat into it in our contracts folder. It is contracts folder. Inside of it, I know it's weird, but I couldn't think of any other name. Backend, smart contract, I don't know. I said contracts. You can name it whatever you want. Now it gives us an example lock contract, which will delete and change the name to just a moment. Yeah, you need a little bit bigger. Yeah, just a moment. Let's change it to staker. Okay. Actually, let's create a am I calling that? Just a moment. External contract. Yes. Just a moment. I have to check something. Okay. Sorry about that. I just needed to check something. Before starting our staker, let us create another smart contract that is called external contract.sol. Why? Like, you know, at the beginning I talked about we want to do something, like as a group we want to do something, like we want to buy an NFT or something, or send money to somewhere or something like that. In this tutorial we are not going to deal with that external contract. Like, we are not going to create a whole NFT and try to buy it. We are just going to create a basic external contract that which we can call via our staker.sol. So what you see here is that it has very basic structure, a boolean of public completed, and we can call that complete function to mark the contract complete. That's all. We are not going to go over that. And just a moment again. Okay, so let's start. Am I recording? I am recording. Let's start with staker. So there are some things. Can't I make this? Yeah, this go. Okay, so this is okay. I haven't talked about my audience, like who I think will my audience be. I haven't talked about that. So let's start here. Let's think that you are completely new to Solidity development, okay? Because that might be easier to go over. Here, all Solidity contracts start with this SPDX license identifier. Here we give unlicensed. We can give MIT or any other thing. It's not important. It's important, but not important in our case at the moment. Then we have to specify the Solidity compiler with this Pragma Solidity. This is from Hardhat. We can use that. I'm not going to use that. Then we start the contract by the contract keyword followed by the name that we want to give our contract. So yeah, I'm just checking if it records correctly or not. Yeah. Now we have to no. This is all wrong. I guess I didn't check. I don't want to use it right now. So first we have to think about what we want, what kind of values that we want in our smart contract. Of course we will have our functions, but those functions should deal with some values. So what I want I want to put a threshold, 1 ether. Okay, I want to put that. That's somewhere. I want to keep track of deadline. Like I want to set a deadline. I want to see how much money has been staked, how much money has been put into the contract, so that we can see if it's gonna execute or not. Because if we don't reach the threshold, it's not gonna execute, so that we can, every single individual in the group can withdraw their money. And also I want to see how much money a particular user, which is say I, have staked to the contract. Let's start with that, because that's the weirdest one, but very useful. Yes, very useful in Solidity. So if you are a JavaScript developer, like I learned Solidity coming from JavaScript, and I didn't know TypeScript at the time, so it was very confusing. So here I will try my best. For anyone who knows only JavaScript but doesn't know TypeScript or any other advanced, so-called advanced data structures, because here this is a very weird syntax if you are coming from JavaScript, because in JavaScript we will just say, if you want to create something named balances, we will just say let or const balances. But in Solidity it doesn't work like that. You know, in TypeScript, if you know TypeScript, this will make more sense, because in Solidity you have to define the type of your variable, so I want to create a variable, a mapping, something called mapping. It's a data structure. I want to create a mapping called balances that is public, that takes an address and points into some uint256, which is a number, very very big number. So what is this like? So mappings in Solidity. Okay, I don't think I'm extremely qualified to explain mappings. I guess some other languages have them, the dictionaries or something like that. I'm not entirely sure. They are like objects and arrays, but they are non-iterable, so you cannot do for loops in them. And they exactly, like, they are very fast. You know, you give some value, you know that value, you give a value, and it points to something in that value. So what the hell? So let's say I make mapping A to B. Whenever I give A, it will point to B. It won't point to C or D or anything else. And in Solidity, in smart contract development, they are generally used, mappings, in many other cases. Like alongside with many other use cases, they are generally used to keep track of addresses and their interactions. So here, what we are doing is we are creating a public mapping called balances that will take an address of a MetaMask wallet of a contract, and will show how much money they have put into the contract. That's what it's gonna do. Okay. Now let's create our threshold. uint256. So uint256 is another. By the way, again, sorry. Address is another type. uint256 is another type. There is uint I guess uint64, like the biggest one being uint256. This is a very 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 big number. So we put numbers like that in Solidity, and we are going to create a threshold which is public and which is constant. We don't want it to change. 1 ether. Then I want to put the deadline, again uint256, public deadline equals block timestamp, whoa, not 30 days, 72 hours. it's cool actually. You can write hours, minutes, seconds, etc. And we are going to put a public of total staked. Wonderful. Wonderful. These are the values we need. Now, to start with, remember, we want to stake, we want to deposit some money into this contract, you know? So let's write function, and this is how functions start in Solidity, pretty similar to JavaScript, eh? Now, this function should be public so that it can be called outside of the contract, and it should be payable, which means that this contract can take money, get money, you know, like you can pay money to this contract. It means that here, and we have to put that, otherwise we cannot send money into it, and we want to send money into it because this is our stake function. I'm again checking if we are recording or not. I'm sorry about constantly checking it. Okay, so inside of this function I want to put a require statement. This is a Solidity stuff. It's like an if statement, but it requires that block time stuff, which is the exact time that this function is being called, is smaller than the deadline. So like you should, which means that you can only call this function when the deadline has not been reached. So like if it's bigger than the deadline, which is block time plus 72 hours, you cannot call this function, and you will get staking period is over error. It always confuses me for some reason. I don't know why. Mappings too, they confused me a lot. But that's how things go. And we could have written a modifier, but I'm not going to do here. Now, what we want to we want to add some money. Okay, we want to add some money, and we want to keep track of that money. If you remember, we put a mapping named balances. Now we have to make use of that one. How? Well, this is how we call balances. Message, yes. Okay, so these two, message.sender and message.value, these are built-in values in Solidity. Message.sender means the address of the entity, the contract or person or wallet that's calling this function, and message.value is the value that's being passed in that call. I know, weird, but that's how things work. Okay, like so if I'm calling the stake function, I am the message sender. You know, if you are calling the stake function to put some money in it, and you are putting sıfır, oh my god, I said sıfır, which is 0 in Turkish. I'm sorry about that. The mother tongue is always snaps back. So for message, if you are passing 0.2 ether into the stake function whilst calling it, the message value will be 0.2 ether. Okay, so now also I want to increment the total staked, which is here, to see like if we are gonna reach the threshold or not with the message value. Wonderful. Let's call our withdraw function. Not call, sorry. Let's write our withdraw function. Function, let me adjust this microphone. Oh, you chill. Function, did it work? Function withdraw public. And yeah, exactly, we are going to require two things. Now, first we require that the time when we call this function should be equal or bigger than the deadline, which means that it should pass the staking time, so that it should check, because in order to withdraw we have to wait for this staking threshold to be passed. And then we require that the total stake is smaller than 1 ether. Why? Because we said our threshold is 1 ether, and if we cannot reach that one as a group, that means we couldn't come into an agreement, we couldn't get the required amount of money, so we can withdraw our money. But only if these two statements are correct, we can withdraw. Otherwise we cannot. As you can see, threshold is already reached, you have succeeded but can't withdraw anymore. Yeah, which means that if you get this one that means that you have succeeded in your endeavor to get the enough amount of money to do this or that. Now this is always confusing. This is a very weird syntax in my opinion. Exactly, this is, gosh, look at this. So I'm checking if everything is correct. So this is, oh, what is going on? I'm checking something on my second screen. Sorry about that. Now yeah, so this is as message sender, the entity that is calling this withdraw function is calling the value which is the amount of money that is in the balance of the person or entity that's calling this function. So basically it's trying to get this amount of money to itself. I know it's weird. Anyway, we put another require that success transfer failed. So then what we want to do we want to do this, and I'm going to explain. Yes, so here since we withdrew our money, we want the balance of the entity that's called this function, the message sender, to be 0 because we withdrew our money. So I called it, my balance was 0.5 ether, I called it, I got my money back. So in this contract I shouldn't have any balance because I got it back. And here I'm decrementing it, balances in brackets message sender, from the total stake, so to keep track of stuff. Now let's write our execute function, which is the function that will be called if we can reach an agreement, if we can get the required amount of money, and that we can do something with it. In our case we can call external contract sol. Now again I'm putting some require statements. The first one is the same with the other one. As you can see, in order to execute we want the staking period to be over. Then we want the amount of money that's staked equal or bigger than 1 ether. Like, this is our logic, okay? It can be 5 ether also, but it has to be bigger than 1 ether because this is the minimum amount of money we need. If we cannot reach that money, again we will call the withdraw function. Everybody will call withdraw function and get it back. Execute can be called by anyone. As you can see, threshold is not reached, you can withdraw your funds. Okay, now I forgot to import external contract. Sorry about that. Let's import our external contract, which is like very JavaScript like. We just imported this because right now we are going to use it. You know, like this is where we call it. Let's call it. and exactly like this. So here we are too many external contracts. Here we are creating an external contract with lowercase letter e. In the type of external contract we are importing, which is a new external contract. Yeah, it's weird. I know. This is these two, as you can see, uppercase. So this is the type. Like I could have named it lolly or something like that. I don't know. But I'm going to name it external contract, so it will be understandable. So this is the name of the variable, this is the type of the variable. So like mapping or address or something like that, but we want our external contract to be in the type of external contract. So this is what we are doing, and now we are going to call the complete function here. Remember, it's payable. So that means you can send money here. So external contract, you see I'm calling with the lowercase because this is the name of our variable. This is type, this is the contract. Complete, yes. Now value, I am doing something very wrong. Curly braces. Yes and yes, and this is our syntax. Like I'm calling this complete function with the value of the balance of this address. Yes, so this refers to this whole contract. Call the complete function, like this means this line 41 means call the complete function in external contract variable that is of type external contract that creates a new external contract that wait here with the value of the balance of this contract. Yes, and since we have done it, like I am not sure if we even need that, but let's do it. Nope, this is not what we want. Yeah, since we sent we call the function, we are we don't have any money in it in this contract anymore, so we define them as we have done before. Now we have one kind of function. Let me copy paste the next one. No, I'm not going to copy paste. Let's not be lazy. Let's go, because I don't know there will be anyone who will really enjoy this tutorial or not. So yeah, but it did do it for me, you know. I didn't want to copy paste, but it forced me. No, it's your decision. Okay, so we have this function time left, which is public view, which means that we can call it with a provider. It won't cost us gas if I'm not extremely mistaken. Returns in 256, and if we pass the deadline, it returns 0. Else, it returns how much time is left, like from deadline to the moment that we call this function. Now we need 3 getters. Yeah, I'm gonna copy paste them because they are easy. So all of them return something. All of them are view, so they are not going to cost us any gas, and we can call them with provider. User balance will get the amount of money that the entity who calls the user balance function have in this function. So if I call this function, it will return how much money I have staked in the contract. Total balance in the same manner will return all amount of money that's staked in the contract, and threshold reached will return a boolean saying whether we reached our desired outcome or not. So basically this is our smart contract. Now we are going to start testing. Okay, so this will be in the next video. Okay, now we have written our smart contract. It's time to test it. Yeah. So luckily for us, Hardhat is a wonderful tool for testing, and it created a test folder, and inside there is this log.js, which we are gonna change the name as staker. We are going to delete everything except these. So, you know, testing is quite a big thing in smart contract development, so we have to do it. I couldn't sit right. Okay. Let me start by defining some variables. Before each, not this I don't like it. This is wrong. Async function. What is this? Now I want to get let me write first, sorry. Now what I'm doing, Hardhat gives us lots of I think around 20 wallets with lots of ether in them, so we can do testing with it. I'm going to show you right now. So you remember the HH, so npx Hardhat node will open up the accounts that are coming with Hardhat. As you can see, all of them have 10,000 or 1,000. Oh, 10,000 ethers. I'm not seeing it wrong, right? A lot of ether. We have the account address and we have the private key. We are going to make use of one of them too. So here what I'm doing, where is it? Here I'm getting 2 of them, okay? Because I want to test whether anyone can stake it. So I'm going to use those wallets here. So this is one wallet, this is one wallet. Now const staker equals we are getting the staker contract, which is this contract. We have to deploy it, and let's for the deployment. So what are we doing here? Before each test, we want these wallets to be taken and this staker contract to be deployed. This is what we want. Now let's create inside of here, because I want to make use of that before each statement. Describe, no, correct it, deployed with the correct values. So I want to see whether some of the stuff when we deploy are correct. So let's start it. Staker should have 0 balance. Async function. Oh. Expect. If you are new to Yeah. Yeah. If you are new to testing, what we are doing here, basically, I copied pasted for the staker too. What we are doing, we are getting the balance of the address of the first staker. We are checking, we are trying to get the address of the first staker, and we expect that to be equal to 0. Why? Because when the contract is first deployed, no one has staked anything, so everyone's address should have 0 balance. And see, balances our mapping. Yeah. And let's test it. Yeah, it passed. So let's continue. Now I want the threshold to be 1 ether. Okay, I'm just going to copy paste the first line. Tuck. So exactly, yes. So we are expecting the staker, which is the staker contract that we deploy here, threshold to equal to 1, and we have to use these ethers utils parse ether, because this 1 is a very big number. If we don't parse it, it's like 18 zeros or something like that, so we parse it to see it as 1. We are gonna see more of it on working with the front end. Now let's test the stake function. Now let's first check whether it passed or not. Yes, pass, to passing. I don't know if you can see it. Let me see. It's small for you, I guess, but I don't know how to make the terminal bigger, so you have to contend with it. Let us continue. Let us continue with the stake testing. This describe. Yes, stake. It address 1 should stake 0.2 ether. Async function. Whoa. I accidentally pressed print screen. Await staker dot con. Okay, now I have to explain this part. Skater boy. That stake. I'm going to explain. Sorry, first I want to write it. Yes, exactly like that, if I'm not mistaken. So what I want to do, I want to call the stake function in my staker contract, which we deployed here. Now what I can do, I can connect to one of those addresses that I have shown you, given by Hardhat, because I have to call the stake function from someone. You know, someone has to call the function. So after writing the name of the contract, I can connect to a particular staker, in this case staker 1, and then stake it. It's called the stake function with the value of 0.2 that's parsed in parse ethers, because as you remember, stake function is payable. So you see, message value, we have here our value, we call it. Now, well, since it's all nice, we passed it. Now we have to expect something, right? We expect the staker again. If we wanted to read these lines in human language, it says get the balances of the first staker in the staker contract and expect the balance of that staker one to be equal to 0.2, which we have made sure here. And I'm going to add another one which will expect it says get the staker contract, get the total staked from here and it should be equal to 0.2. Why? Because only one staker has staked and they staked 0.2 ether. Let's test it. There's yeah, it passes. And now let's see what will happen if I say 0.3. Let's test it. Fails. You see, it expects 3. This I told you this is a very big number here. It says it expected this with 3 but got with 2. Why? It expects it expects 3 because we told it to expect 3, but we gave it 0.2 ether, so it's not gonna pass, so we have to fix that. Now let's check withdraw function. That's a little bit longer, but this is like we have to write tests because I mean we cannot do things manually, you know. Maybe in basic JavaScript projects you can get away with it, but with blockchain development you cannot. You know, people lose extreme amount of money, lots of money because they didn't test correctly. I'm not saying that we are testing wonderfully, but at least we are testing something. And you know, in real life, in real world scenarios, you audit your code, you pay for someone, you pay someone to basically attack your code from everywhere so that you can see what is wrong with it. Let me copy paste. Why? Because we are doing the same thing, you know. What we are doing, what are we doing, what is this? The same thing. I'm connecting to the staker 1 and I'm staking 0.2, and then I'm checking whether the staker balance is the same as I've staked and whether the total staked is 1. So right, we said 72 hours, right? I guess here I'm not sure. Let me we're at 14 minutes now. Things should be interesting. Why? Because when I wrote this contract, I set the deadline to 30 seconds after the threshold to 30 seconds after deploying the contract, but right now in this video we made it 72 hours. So the thing is, in order to withdraw, we have to wait for the deadline to pass. So let's see, wait for 72 hours. I don't know if it will work. Await Ether's provider. I hope it gave me the correct time. Did it? Yeah, just a moment. We are not in here. We have to go up. Like. Yeah, okay, we are going to check it together, because I don't know if this one makes 72 hours, you know. If it doesn't, I will pause the video and check out. Let's try. I wonder it myself, and if it passes, I will explain what's going on. Let's see. Oh my god. And let's try something. Let's try. It's wonderful. Okay, wow, Copilot. Okay, so what is going on here? You know, if you remember, in our withdraw function, we have required statements that it should be it shouldn't be reached to 1 ether, and it shouldn't be whilst the staking period is going on. So if we are still in the 72 hours, we cannot withdraw. So here I stake money, you know, like the previous versions. I connect the staker one, I stake some amount of money, and then I checked whether it's in the balance of the staker one, and then I check if it's in the total balance. Then I wait for 72 hours, which is, I guess, in seconds or something like that, calling this EVM increase time, and I'm waiting. I'm mining, and then I'm calling the withdraw function whilst connecting to the staker one, and after withdraw function I expect the balance of the staker one to be 0. Wait, this is weird. Why? Like by balance, I don't mean the balance in their wallet. I don't know if when we say balance in this contract, we are not talking about the balance in their wallets. We don't know about that. It's their balance in this contract, which increases when they stake, and when they withdraw it should be 0, and it passes. So everything is fine here. Why didn't it pass? Because I deleted 10 to see whether it's correct or not, and it's correct. So if we don't wait for 72 hours, we cannot withdraw. You see? Staking period is not over. It's wonderful. So we know that works too. We have 2 more tests. I hope you are enjoying it. I'm enjoying it, actually. Now I'm gonna copy paste, and you are gonna see. Oh, we are still in. Oh yeah, sorry. We are still in there. Yeah. See, I told you I started with 30, and let's write it. Let me check something. Yeah. Now let's change this. 72 hours. So you should, like, the user shouldn't be able to withdraw until the required amount of time has passed. I'm gonna copy paste because this is basically the same thing we have done above. So you see, I have the staker contract. I connect with staker 1 and stake some money. Then I expect the balance to be 0.2 and total balance to be 0.2 because only one person put 0.2 amount of Ether. And then I expect, connecting to this staker, I call the withdraw function without waiting for 72 hours, and it should revert because we are the staking period is not over. It should revert, which means it should pass. Can't withdraw before 72 hours has passed. So that functionality works too. Now let's write, this is the last one. We are going to work with execute function. Describe execute async function. Oh, yeah. It should execute properly. That's what we are going to do. Of course, you can write many tests, but this is what we are going to do. Now, yeah. You know, we will start by sending some money to our contract, and here we are gonna make use of the second staker that we have defined, remember? So we are connecting to the staker contract with staker 1 and staker 2. With staker 1 we are staking 0.5, and with staker 2 we are staking 0.6 Ether. Now we have to wait for 72 hours because if we want to execute before 72 hours, we cannot call the execute function, right? That was our deal. So wait for 72 hours and then await staker execute. Now what do I want? I want the balances of staker 1 to be 0. I want the total staked amount to be 0, and let's add, I want the balance of staker 2 to be 0 also. Let's check. There is a problem. Just a moment. Wow, something wonderful happened. I just paused the video and have been looking at my code, and this is why we test, guys. Like when I first tested this contract, what I did, I didn't use these. Okay, let's first see what's going on here and why did we get an error. Okay, this is interesting. I wasn't expecting that. I didn't know that I made a mistake, but it was a pretty obvious mistake. It's wonderful. This is why we test. So it failed. Why? Because here I'm staking with the staker 2, I'm staking with staker 1, and then whilst on pause I created another staker here. It's not really important, but to try to understand, I created another staker 3. So they pass the threshold of 1 Ether, but when we run the function, and I change the staker function a little bit too. I am connecting the function via staker 1 because someone has to execute the function, I guess. It failed because in our staker function, in our execute function, where is it? In our execute function, we said make the balance of the entity that is calling this function 0, but we didn't tell anything about making returning the balance of other stakers 0. I forgot that. I totally forgot that. I mean, and the test found it, and that's why it was not passing, because the staker 1, it was the caller of the execute function, so its value was going to 0, but the others too, they were not going to 0, so it was expecting the balance of staker 2 and 3 to equal to 0, but it was not. So what did I do? I asked ChatGPT. Well, of course, I had to change some things. What did I change? First, let me get a sip from my coffee. First, I added an public address of stakers. This is how you create a public array of addresses that's called stakers. This is how you create an array in Solidity. This is an array of addresses. So this array cannot get you into 56 or any other thing. It can only contain addresses. Now, with each stake, I'm pushing the caller of that stake function, the entity that calls the stake function, the message sender. I'm pushing it to this stakers array so that I can keep track of them. Then in my execute function, before it was like this, I'm creating a loop. Oh yeah. I'm creating a loop that loops through the stakers array of addresses and turns them turns their balances into 0, and then it turns the total stake to 0 too, and then deletes the stakers array. I didn't even know that this delete exists in Solidity. So since we were not turning everyone's balances to 0, but only the entity that's calling the function, we were getting the error. Like, that was a huge mistake. So let's test, and it should pass. It passed, because right now we are making sure that everyone's address gets, where is it? Gets 0. Okay, that's all for testing. In the next video, we are going to start the front end. Let me close that. So see. So I know I said we are going to go to the front end, but I was wrong, because we didn't deploy our contract. So what we will do now, we have to configure some stuff so that we can deploy to localhost. So this is how I will change my Hardhat config. As you can see, I'm specifying the version. I say settings. Like, this is basically, I'm leaving as it is. Actually, like, I didn't have to do this because we are going to deploy to localhost. That's the host, the blockchain that Hardhat provides us with. If you want to deploy to a test network, we will have to specify that here, like the Mumbai test network, Sepolio, Gerli, whatever, or a mainnet. We will have to specify things here in Hardhat. But since we are going to deploy it to the local network, we don't have to do anything. Now let's delete this. Let's require ethers from Hardhat. Yeah, it's weird, right? But we require ethers from Hardhat. That's how it works. Now, yeah, I'm just going to copy paste it. This is so easy. Like, here we are getting the contract factor staker. We are deploying, waiting for deployed, and we are getting the address here. And then this is how you catch errors. I'm gonna share the code so you can check it. There's not much I can talk about it here because we have covered these in testing part. Now I want to deploy the contract. Let me do it here. Now I will have to divide my screen because at one place I'm going to use the NextJS app, and one place I will run the Hardhat node. So let's cd into contracts. Let's write HH node, which will start a local blockchain, and these are the accounts that it provides us with. And now HH compile will compile. Yeah, compiled our smart contract and it done. Voila. Now our contract has been compiled and deployed to this particular address. Now we can go to our contracts, and now we will see there is an artifacts folder which has contracts and which has another staker sol folder that has the staker JSON file. We will need this ABI. So let's copy this. That's ABI. Let's copy this. Now I want to go to my NextJS app, so and create a constants folder. Inside of it, create an index.ts file, export const ABI equals to this one, yes. And then I want to export const, yes, but I'm not sure if that's the correct contract address. Let's copy and paste here. Now in my where are we? We are in the NextJS application. Now we are on the front end part. Okay, yeah, it took a couple of minutes for us to deploy. Now we have to install npm ethers, and yeah, ethers is enough, I guess. NextJS comes with .env, and we are not going to use .env. Are we going to use anything else? I don't think so. Okay, so now when we installed the ethers library like this, it installed with the latest version, which I've talked at the beginning. So this code will be different from most of the tutorials you will find online, because again, as I said, this is a very recent stuff, and most of the tutorials are using version 5. You can install version 5 and you can follow the documentation or follow GitHub Copilot. This is how I wrote this application. I knew how to write in version 5, but I didn't know how to write in version 6. So I checked Google Copilot and stuff, and it works. So, and the changes are very easy to migrate. So what are we going to do? Let's start our development server. Let's npm run dev. We'll start a development server at localhost 3000. We are here. Now what do I want to do? I want to go back to yeah, whatever. Just a moment. Yes, this is. There is my. Let me close this part. Yeah. Where is my styles? Global CSS. I am not going to use this. You see here, there are our Tailwind classes. They come with the script that we use to install our NextJS application. So, and Let's go to our index.tsx section. Et voilà. Now, you know what I'm gonna do? I know now the thing is, alright, what's this? Yeah, we are done with this. Now we have our ABI here. We copied and pasted it, but that's actually just to show it. We can get our ABI by following their path too, and this is where it is. You know, I named it Staker ABI from here, and just a moment. Let them be named like so. Staker ABI address. Oh yeah. Just a moment. Let's get our address here. I'm a bit confused. Sorry about that. Port. That is wrong. This should be correct. If not, we can use it. Oh. Actually, I'm just gonna take it. Bam. Because why not? We can show our contract address. And for ABI, this is the Staker ABI, and like this points to this JSON file, and in order to get the ABI, I'm gonna select it like so. Now we have to do certain things. We have to declare a global because we are using TypeScript. Otherwise we are going to get errors. Now I'm going to put some stuff here. So first of all, from React we get the use state and use effect hooks, like the holy duo, you know, like the most important ones. We imported the address library, we get the Staker ABI, we get our contract address here, and here I'm defining certain states. Is wallet connected? Actually, I don't need that, but I defined deadline, threshold, staked. These we have to define whether they are number or not. And this is how you define the types of use state in React with TypeScript. User balance, total balance, count. Okay, wonderful. Now I'm going to add a helper function, which I always use to re-render the page. This is one way to re-render the page. So with this use effect, whenever the count changes, it will re-render, and I want to do that. And this is very easy, basic way. I don't know how performant is it, but I mean it works, and I'm not sure. Now, first we have to connect to our wallet. First. You know what? Yeah. Just a little moment. This is wrong. You are wrong. Could you please close the div? Yeah. I'm not going to go over the Tailwind CSS styles, and as you will remember from the start, they are not extremely important or artworks. I just want to create a button for connecting the wallet. So I gave it, and now we have to create the functionality. Let's do that. Const connect wallet is an async function, and inside. Now this is where I found this. We go to the documentation, and it shows us how we can connect here. Like I'm using this one. I'm not using JSON RPC provider because I'm not using an RPC. Like Infura, something like that. Quick note. I got that there. So yeah, I am going to copy paste it and explain, because that's a lot of code. Now we have our yeah, let me change it. This is better. Yeah, all good. Let's see if our yes, everything's perfect. Now let me explain. Since this is an async function, we have a try catch block. This is how I always write async functionality. I don't like then that callback hell. I like async await in try catch. We define a signer and provider. Signer, here it explains. So you can read it here. I'm not very good with explaining their underlying principles, but basically with signer we can connect to the blockchain and we can read data from it, but we cannot write data. For that we need provider. So if we know that Ethereum is null, say MetaMask is not installed, use this whatever, if it's not full null, connect to MetaMask, and then this is our provider, and this will get the signer from provider. We are setting the vault connect to true. We are not going to use it in this application, but I put it whilst developing because it comes naturally, you know. Then I'm console logging this so we can see, and we are catching errors. Let's try if we can connect. Before connecting, you see I have a lot of ethers. No, I don't have it. What did I do? You see I have my account here and I have Hardhat 0 here. So I imported the Hardhat 0 account into my MetaMask so that I can use it in development. What do I mean? Let me show you. Let's get the second one. So in order to import it, I need the private key of the wallet. I copy it. I go here. I click import account. Yeah, import. Ta-da! And I want to change the name of it. How do I do that? How do I change the name? I want to, yes, Hardhat 1, so that I will know. Hardhat 1. So since like what's going on here? In order to do stuff, I need to use Ether, and since I'm in local development, I can use Hardhat's own wallet, and since it gives the private keys, I can just import them. So I'm going to use this account to do stuff here. I press connect wallet. It connects. Yes, we are connected. By the way, something I have to mention. Also, There is this Hardhat network. How do you do it? You go to your settings. In the first place, let's go back again. Settings. No. What did I do there? Oh yeah, sorry. I get a brain fog for a second. So I click here, networks. I click add network if I don't have Hardhat. So I assume you don't have Hardhat configured in your MetaMask because it doesn't come built in. Here I go to add a network manually, and it will take me to a place where I can pass this Hardhat, this RPC, this chain ID, and this symbol, and add. I cannot add right now because I have already added, and you see these are the ones I added: Celo, Mumbai testnet, etc. So you have to add this into your MetaMask. I know it's too much work, but this is it. Blockchain development requires a lot of stuff, a lot of moving parts. So if you are into it, good. If you are not, well, too bad. This is how it is. Okay, let's write our other functions. I'm tired. So yeah, this I need to write. This I need to write. Const get threshold, yes. Now what do we do? First we get the provider. Why provider? This is wrong. This is wrong. This is completely wrong. Well, this is a read function. And this doesn't exist in the new ethers. You know, that was wrong. So this is how we write it in new ethers update. We are getting to provider because this is a read function, and we are not going to change anything in the blockchain. We are just going to read data from it. So const contract new ethers contract address ABI provider. This is how we get the contract. So we have the contract right now. Let's const threshold await contract threshold. Yes. Yeah, that's actually better. Before the update, this is how you will write, but now we don't use utils. So we have to format our threshold number, because from Solidity it's weird. It's gonna come a very big number, so JavaScript won't be able to read it. So we have to format it using this formatter functionality. Then this is how I did it. And then to set the threshold, because here I set number, I turn the threshold in Ether, the formatted version, into number. I format it again, I console log it, and then I increment the count I call this function so that the count will be incremented by 1, so that it will re-render. Yeah, too many things, right? Now let's call our stake function. Const stake. Yes. Now since we are going to write data to blockchain, because we are gonna put some money in it, we need the signer. Yes, and this is how we get it. Now let's contract. Yes. Now we are calling the stake function. Now let's see. It's quite basic, right? and again we have to delete the utils because we don't use it anymore. 0.2. Let's take 0.2. And I want to do these three. Now this doesn't exist, and let's write it. Actually, we can copy paste them because they are very easy. We have covered them. Get total balance, get user balance. Like, you realize these are all the functions that we have defined in our Solidity contract. Like, I mean, this is how I came to understand what blockchain development is. It's obviously backend, but instead of making API calls, you use these ABI that we have here. So it's like that, like it's a whole, like a big database, someone said, I guess. Get user balance. For some reason we use signer. Do we need signer? I guess we needed signer here. You can check the code. This we covered here with the ones that we have done. You see, like we get the provider, we get the contract, we get the balance. We are calling the total balance from the contract. We set the state, we increment the count. Here I don't remember why, but we get signer, and we do the same things. Now let's write the execute function, which is, yeah, you can check it again. This is basic. I'm not sure if I'm doing something correct or wrong here because I'm not connecting to anything, but I guess it's okay. I don't know. If, like, please tell me if there's something wrong with here. And for the front end, I'm just going to copy paste, honestly, because it's a lot of boilerplate. And you can check it. I'm gonna share this code. I'm just putting the buttons for this function, and let's check. Now we have it. Are we connected? We are connected. Get user balance 0. Execute should failed. Yes, because like staking period is not over. We cannot. Oh yeah, I didn't put I didn't put the withdraw button here, and I think I'm not going to put it because we are not going to be able to withdraw either, because we said we cannot withdraw before 72 hours has passed, and I don't want to change the contract to make it like 30 seconds or something like that. I believe you got the gist of it. You can just add a withdraw function and see, and we already tested. So let's try with stake. Confirm. That's, yes. Remember the error at the beginning, the annoying one? Stake. And it should work. Waiting. Come on. Did it work? No, not yet. I'm just waiting. Yes. Yes, you see, user balance is 0.2. This is wonderful. This is wonderful. Let's for some reason there is a problem here, but I will let you deal with it. This was a long long tutorial. Like normally it should get the, let me see why, just a moment. What was wrong with that? What's wrong with you? Why? Why? Need, where is it? Threshold. We are having problem. Of course. I'm not calling the get threshold balance, and I'm expecting it to return the threshold. That's not gonna happen. If you don't call it, it's not gonna return. So this is let's take another. Come on. Let's take another one. We are waiting. I'm gonna sip from my coffee. Tada! Now you might be asking, well, wait, weren't we putting 0.2? Well, in order to check it, I copy pasted my own code, which originally I used 0.3, so don't get confused. That's why it got 0.5, and that's it. I'm not going to deploy it into a test network. I'm going to content with being in the local network. I hope you enjoyed the tutorial. I hope I was able to help at least one person. If you have any questions or suggestions or corrections, please don't be shy. Let me know, let everyone know, and have a great day. Keep coding. Ciao.